Hi all, today's class is about another prefix coding, that is an important class of prefix coding, that is SHANNON FANO algorithm. In previous class we studied one of the important prefix code, that is Huffman coding. So now we can see what is SHANNON FANO algorithm. So first we can see what is the procedure of this SHANNON FANO algorithm. So first step is list the source symbols in the order of decreasing probability. So the first step is same for Huffman coding. So we need to list the source symbols in the order of decreasing probabilities. After arranging the source symbols in decreasing probabilities, second step here is that we need to partition the symbols into R groups so that the sum of probabilities in each group is approximately equal. So if you have R source code, R code alphabet, if you have R code alphabet, then we need to divide or we need to partition this symbols into R group so that the sum of probabilities in each group is approximately equal. So we need to divide the symbols into R group in such a way that the sum of probabilities in each group should be equal or nearly equal. Then the third step after partition, the third step is assign each group using a symbol from code alphabet. This form the starting code symbol of the code. So after grouping this symbols into R group, each group is assigned a code alphabet. So the code alphabet consists of R symbols. So we are assigning a symbol from this R symbols for each group. Then the first group after this coding, then again we are dividing the first group into R groups such that each subgroup probabilities are the same. So after first we are dividing this entire symbols into R group, then each group again we are subdivided into R groups. So the condition is that the probabilities in that R subgroup, if we are added the sum of if we are added the probabilities, then each subgroup have nearly same probabilities. Then again we are designated each subgroup with R symbols from this code alphabet. So each subgroup we are assigning a symbol from this code alphabet. Then we can repeat this step 4 and 5 for every subgroup until there is no further division is possible. That means only one source symbols are alone. So that time we can, then in all the steps we need to assign each group with a source symbol from the R code alphabet. Then after this our coding is over, then we can read the code directly. In Huffman coding we read the code backward. That means we are doing the backward trace to obtain the code, but here the code is we can obtain directly. That means in forward direction itself we will get the code. So that's the SHANNON FANO algorithm. So we can remember the steps once more. So first we need to list the symbols in decreasing order of their probabilities. After listing the symbols, we need to partition the symbols into R groups in such a way that the sum of probabilities in each group should be nearly equal. Then after that we are assigning each group using a symbol from this R code alphabet. After that again each group is again subdivided into R groups such that the subgroup probabilities are same or nearly equal. Then again we are assigning a source symbol from this R code alphabet for the subgroup. Then this step repeated until we have only one source symbol. Then to read the code, we can read the code directly. That means in forward direction itself we can read the code. So this is called SHANNON FANO algorithm. It's also known as prefix code. So next we can see one example for this SHANNON FANO algorithm. So here we have a messages from S1 to S8 are the symbols with probabilities 1 by 4, 1 by 4, 1 by 8, 1 by 8, 1 by 16, 1 by 16, 1 by 16 and 1 by 16. we need to find what is the Shannon FANO coding for this symbols. So first step, we need to write the symbols according to their decreasing order of their probabilities. So we can see here that in question itself the probabilities are in decreasing order, so there is no need of any alternation of source symbols. So we can write the source symbols from S1 to S8, then their corresponding probabilities. If any change in this decreasing order of their probabilities, you can write according to that. So that's the first step. We need to list the source symbols in decreasing order of their probabilities. So that's the step 1 process. Then in step 2, we need to divide this symbols into 2 groups. If it is not specified whether it is binary or ternary etc., not specified, you can use binary coding. So we need, in step 2, we need to divide this source symbols into 2 groups. The condition is that each group having probabilities, if you are added the probabilities of each group, that should be nearly equal or equal. So here we have 8 symbols are there. So the first 2 symbols probabilities are 1 by 4 and 1 by 4. So we know that if we are added 1 by 4 and 1 by 4 together, then you will get 0.5. So how we can divide this means, first you start from S1. So you keep S1 alone. Then that's probability is 0.25, and the remaining if you are added you will get as 0.75. Then you add this x2 together. So S1 S2 as probabilities become 0.5 and remaining is 0.5. So now we got a group division in such a way that group 1 also and group 2 probabilities are same. So this way you can divide the source symbols into R groups. The condition is only that the each group, if we are added the probabilities of each group, that the group probabilities should be nearly equal or equal. So that's the only condition. So here we group S1 S2 together. That means we are divided S1 S2 and the remaining together. We are divided S1 S2 together and the remaining symbols S3 to S8 together, because the probabilities of first group is 0.5 and the remaining is also 0.5. Then we coded that source symbols as 0, and then again the remaining we are coded as 1. So we can see in step 2 we are coded this S1 and X2 as 0, then the remaining symbols are 1. So we can also code the S1 S2 as 1, and that means upper group as 1 and lower group as 0 also. There is no problem in that coding. So here we did the upper group as 0 and the lower group as 1. So next we need to again consider each group separately. Then we need to divide this group into subgroup. The condition is that sum of the subgroup probabilities are nearly equal. So first we can consider the first group. So the first group consists of S1 S2. So we can divide S1 alone and S2 alone. Then we can give the coding of 0 for S1 and 1 for S2. So there we can see that we are already coded 0 for, in step 2 we are already coded for S1 and S2 as 0. So that 0 we need to consider. So at step 3 S1 is coded as 0 0 and S2 is 0 and 1. Next we can take the second group. So again the second group consists of 6 symbols. We need to divide the symbols into 2 groups having nearly equal probability. So we can group this S3 S4 together and this remaining all together. So if we are grouping S3 S4 together and the remaining together, then we are giving S0 for S3 S4 group and a 1 for the remaining group, that is S5 S6 S7 S8. So in step 3 we can see that S3 S4 is coded as 1 0 because 1 is already we coded in step 2. So 1 0 is the code for now for S3 and S4. Then the remaining is coded as 1 1. In step 4 we can see that S3 and S4 are there. We need to divide this S3 and S4. Then S3 is coded as 1 0 0 now and S4 is coded as 1 0 1 now. Then we can take the remaining group. So in now the remaining group consists of 4 symbols. Then we are dividing that into two groups. So we can see that all the symbols probabilities are 1 by 16, 1 by 16, 1 by 16, 1 by 16. So we can group them, group two symbols together. That means S5, S6 together and S7, S8 together. So now at step 3, the code of S5 and all the symbols are 1, 1. So at step 4, S5, S6 code is 1, 1, 0 and S7, S8 code is 1, 1, 1. And in step 5, we can divide S5, S6 and similarly S7 and S8. Then S5 we can code as 1100 and S6 we can code as 1101. Similarly S7 we can code as 1110 and S8 we can code as 1111. So the only thing is that first we need to arrange the symbols in decreasing order of their probabilities. After that we need to group the symbols into R group. The condition is that sum of probabilities of each group should be nearly equal. Then again we are dividing each group into another group, R group. In that also the sum of probabilities of subgroup should be nearly equal. Then each group we are assigning a 0 for upper portion or a lower and a 1 for lower portion. We can also code 1 for upper portion and 0 for lower portion, but the only thing is that the same method, same coding you should keep in one problem. So that means every upper group you need to group as 0 or you need to code as 0, and every lower group you need to code as 1. So that's a procedure. Or we can use every group, every first group you can code as 1 and every second group you can code as 0 also. So any one of this method you can follow. So the procedure should be same for all the codes. So here we followed the 0 for upper portion and 1 for lower portion coding. So you can see for every so symbols upper the after division upper group is coded as 0 and the lower group is coded as 1. So this is, then we to find the code we can directly read in the forward direction. So we can see that for S1 the code is 00, S2 the code is 01, S3 the code is 100, S4 the code is 101, S5 the code is 1100, S6 the code is 1101, S7 the code is 1110 and S8 the code is 1111. So this way we can code any symbols using Shannon FANO coding. Hi all, we can see more problems related to this Shannon FANO coding. So you are given a messages x1, x2, x3 and x4 with probabilities 0.1, 0.2, 0.3 and 0.4 respectively. Design a code with prefix properties and find efficiency and redundancy of the code. Find probabilities of ones and zeros in the code. So here design a code with prefix properties means we can design using Huffman coding or Shannon FANO coding. See here we are using Shannon FANO coding because we are considering it as an example for Shannon FANO coding. So we can do this using Shannon FANO coding. So our first step is we need to arrange the messages in decreasing order of their probabilities. So we can see that the x4 having more probabilities. So x4, x3, x2, x1 is the symbol and pk probability is 0.4, 0.3, 0.2 and 0.1. So the next step we need to divide the group into we need to divide this symbols into two groups because we are using binary coding. So we need to divide these groups into two symbols with the sum of their probabilities are equal. So you can divide the symbols x4 alone and the remaining together. So then we can see that the x4 having probability is 0.4. So the remaining have probability is 0.6. So then if it is grouped x4, x3 together, then the probabilities become 0.7 and the remaining is 0.3. So better we need to divide x4 alone and the remaining together. So then we need to assign code for this group. So 1 is assigned for x4 and the 0 is assigned for x3, x2 and x1. We can also assign 0 for x1, x4 and 1 for x3, x2, x1 also. So we can use either coding. So then we need to divide this x3, x2, x1 again. So here we can divide this x3 alone and the remaining together, because the probabilities become 0.3 respectively. Then x3 is coded as 1 and the remaining x2, x1 is coded as 0, 0, 0. Then we can again divide this x2, x1 as x2 separate and x1 separate. Then x2 is coded as 1 and x1 is coded as 0. Then we can write the code directly. So x4 code is 1, x3 code is 0, 1, x2 code is 0, 1 and x1 code is 0, 0. 0, 0, 1 is x2 and x1 is 0, 0, 0. So we can find the number of bits in the code. That means code word length, that is 1 for this x4 and 2 for x3 and 3 for x2 and again 3 for x1. So that is the code word length. Next we can find what is the average length. So the equation is summation of k equal to 1 to 4 pklk. That means probability into code word length. So you will get it as 1.9 bits per symbol. Then you can find the entropy using the equation k equal to 1 to 4 pk log of 1 by pk. So then you will get it as 1.846 bits per symbol. Then code efficiency is entropy divided by average length. So you will get it as 97.15%, and code redundancy is equal to 2.85%. So we found what is the prefix code and what is code efficiency and redundancy. And third is find probabilities of ones and zeros in the code. So what is the equation to find probabilities of ones and zeros? So probability of 0, that is P of 0 is equal to 1 by L into summation of I equal to 1 to 4 number of zeros in the code for xi into probability. So we can see that our L is 1.9. So 1 by 1.9 into probability into number of zeros in the code for xi. So we can see that for x1 the number of zeros is 3. So it's 3 into its probability for x1 is 0.1. So we can write it as 1 by 1.9 into 3 into 0.1 plus x2 number of zeros are 2 and its probability is 0.2. So 2 into 0.2 plus 1 into 0.3. Then for x4 there is no 0, so that's become 0. So that is 0 into 0.4. So we can find it as P of 0 equal to 0.5263. Then remaining probability of ones should be 1 minus P of 0. So 1 minus 0.5263, that is 7, that is 0.4737. Or you can find using the equation P of 1 is equal to 1 by L into summation of I equal to 1 to 4 number of ones in the code for xi into pi. So we can write 1 by 1.9 into the number of ones in x4 is 1. So 1 into 0.4 plus 1 into 0.3 plus 1 into 0.2. So you will get it as 0.4737, or otherwise you just find the probability of either 0 or 1. Then 1 minus probability of 0 should be probability of 1. So this way you can find the third part of our question. So next we can